Hi guys. Today's math lesson, we're in a different place. I thought I'd try somewhere different for math class today. So, the thing that I want to do today, and I think from now on problem solving, I think you understand the 4 steps. Understand, plan, solve, and then check. So I want to just concentrate more on the actual problem solving and the different mental steps, the different mental processes that we can go through for solving some of these problems. I think that's what I want to concentrate more on right now. I think you have what steps you need to be doing. So hopefully you've done the understand, you've got your information that you presented, the plan. So on your problem solving and working through this problem solving with a pattern, it's pretty explanatory, pretty evident that the problem solving strategy that we're going to have to use is to find the pattern and then extend the pattern. So we want to see what the relationship is between these numbers. So when we look at 64, we're looking at what is happening between 64 and 32. So in this pattern, what is happening to these numbers? Well, for one thing, they're getting smaller. So we can see that the pattern is decreasing. So that's real important to know whether your pattern is increasing or decreasing. So we can definitely see 64, 32, 16, 8, it's getting smaller. So our pattern is decreasing. And then the next thing is by how much? That helps us. So let's see if when we write that down, if that'll give us an indication of what's going on with if there's a pattern there. So how much is it decreasing? 64 and 32. 32 is how much less than 64. We can look at it, we can say, well, it is exactly 32. Well, of course I would pick up a marker, it doesn't work. Let's try this one. It's exactly 32 less. 32 is 32 less than 64. Well, let's see if that continues. Is that our pattern? Can I subtract 32 from 32 to get my next term? No, I can't, because that would mean my next term is 0. So how far is it? What is the difference between 32 and 16? It is 16 is different. Okay, so the pattern is not, well, we subtract the same thing to get the next pattern. But if we look, the next number is exactly half of the first term. So if we have 64, we get 32. If we have 32, we get 16. If we have 16, we get 8. So there's our pattern. So sometimes your pattern is you subtract the same thing from the next term, but this term we're dividing, okay? So what would we get if we divided 8 by 2? Our next term would be 4. And if we divide 4 by 2, what would we get? 2. If we divide 2 by 2, we'd get 1. What if we divide 1 by 2? 1 divided by 2, we get 1/2. If we take 1 and we divide it by 2, we get 1/2. Okay? So, now the next one, the next term, the last term that we're supposed to find might be the tricky one. And again, we're using a pattern and extending the pattern, but did you see here how I also drew a picture? That helped me figure out 1 divided by 2. What if we do that same thing for 1/2? What is 1/2 divided by 2? We can use this same picture. What if we divide 1/2 into 2? We would get, what's this part? If we have 1/2 and divide it in 2, we get 1/4, because 1/4 and 1/4 is 1/2, okay? All right, so a lot of times when you use patterns, you can use other solving strategies also to help you extend the pattern. So you're not limited. Just because you pick one problem-solving strategy doesn't mean, okay, I have to use that all the way through. You can choose others to help you solve it, okay? All right. Hopefully you guys were able to get that strategy on your whiteboard. So erase your whiteboard. Let's go to our lesson. And our lesson today is a big lesson because it gives us the very fundamental of algebra, and I'm going to show you that when we get to step 5. So it's very exciting to think you guys are well on your way to advanced math. So it's very exciting time. So hopefully you're getting a really solid foundation of math. So here we go. And if you would follow along in your book, we're on lesson 94, and you did your problem solving on page 595. I'm going to be going through each of these examples on page 596, and if you take your textbook and follow along with me, I want you to do that with me today. What I'm trying to do is lead you into getting you ready for your math classes now. I've kind of led you through the lessons and did a explanation, if you will, of the lessons for you. I want you guys to get to where you can look at your lesson in your book, read the lesson, and try to figure out what it is, what is the concept that they're trying to get you to understand. So let's start with that today, okay? We're going to kind of go in a different direction, a different way of doing math, and it's always fun to try different ways as well. So here we go. All right, so if you look on page 596, example 1 in your book. So example 1 says, Jim is 5 years older than Allie. Okay, so I'm going to read the whole problem, and then we're going to break it down and work it, okay? Allie is 2 years younger than Bianca? Bianca is 9 years old. So how old is Jim? All right, that just sounds like a mishmash of stuff, right? It's like, what? All right. What we're going to practice on doing today is where you have a problem and they give you part of the answer, but they don't give you an actual equation to solve. So it's a word problem, but it's not like any of the word problems that we've had before where you can just put a formula up here and work it, okay? You're going to have to pick through what they give you. And the easiest way to do that is you have to write down what they're telling you, okay? So we have to kind of translate. It's the problem. So we're going to translate what the math problem is, okay? So we have that Jim is 5 years older than Allie. So I'm going to take a little shortcut. I'm not going to take my math time to be writing. So instead of writing Jim, I'm going to use J for Jim, because his name isn't important. We're trying to find out the information. So J is 5 years older than Allie. So I'm going to say that he is 5 years older on here. Let's do it this way. I'm going to say that he's greater by 5 than Allie. Okay, now, the way I make my notes and the way you make your notes might be two different ways. It might be two different things, okay? So that's one way to do it, that Jim's age is 5 years greater than Allie. Well, that looks like a minus sign, doesn't it? He's 5 years greater than Allie, okay? These are just notes that I'm making. Yours may look different, and that's okay, because this is not where we're going. We're trying to find our goal. That might be good. Our goal is to find out how old is Jim. That's the last question. How old is Jim? So this is what we're wanting. But it doesn't tell us that he's 43 or that he's 21. We're having to work our way to it, okay? So this is just our first step. This is what we know. We do know that he's 5 years older than Allie. So if we knew Allie's age, we could just add 5 years on and we'd know Jim's. Let's see if they tell us Allie's age. They tell us Allie is 2 years younger than Bianca. So Allie is 2 years younger than Bianca. Okay, we don't know Jim's age. We don't know Allie's age. Okay, keep reading. Bianca is 9 years old. So Bianca equals 9. We do know that. We have a number we can start with. Now, what problem-solving strategy can we use with this? We can work backwards. If we know Bianca's, can we find out Allie's age? Yes, because we know that Allie is 2 years younger than Bianca. Allie is 2 years younger than Bianca. So if Bianca is 9, that would make Allie 7. Now we know Allie's age. Okay, so once we know Allie's age, we need to get to know Allie's age before we can figure out Jim's age. Now we know it. So we know that Jim is 5 years greater or older than Allie. So if Allie is 7, we need to add 5 years on to Allie's age, which 7 plus 5, Jim would be, what is that, 12. So Jim is 12 years old. There's our answer. Okay? So this is what's called a multi-step word problem. They didn't just give us Jim is 5 years older than Allie and Allie is 7. So we would know, oh, well, then 7 plus 5 is 12. No, we had several steps we had to work through to get to the answer, okay? All right, and that is all found at the top of the page on page 596, okay? So let's try the next one. All right, example 2. It says, Javon, maybe it's Javon. Javon paid for 5 pounds of apples with a $10 bill. Okay, so he had $10. It says that his change was $6. So he got back $6. What was the cost of each pound of apple? Okay, well, he paid for 5 pounds. So this would be 5 pounds. This amount is 5 pounds of apples. Okay, so that's a pretty easy problem to find out how much he paid at the store, right? He went to the store, he had $10, he got $6 back. So how much did he spend? He spent 10 minus 6 is, he spent $4. That's what he spent at the store. Now, what is it that we're trying to find out? The answer is, or the question is, what was the cost of each pound of apples? Well, we found out he spent $4, but he bought 5 pounds of apples. So this isn't our answer. What we're going to try to find out now is, now we've got to find out how much each of these pounds of apples were. So to do that, we've got to take this $4 and we're going to divide it by this 5 pounds of apples, because we want to know what is $4 split 5 ways, because that would be what each pound of these apples cost. Okay, so if we set our division problem up, 4 divided by 5, you can't do that. So that's 0. Bring our decimal straight up. Okay, so now we're going to we're going to include not only the dollars, we're going to also include the tenths, the dimes over here. So what if we have 40? Well, can 40 be divided by 5? Yes, 40 divided by 5 is 8. Okay, now, prove it. 8 times 5 is 40. Subtract, we get 0. Because we have 0, are we through? No, because we have only divided this number and this number. We haven't divided this last number, so we're not through. So remember, we divide, multiply, subtract, bring down, 0. Now, what is 0 divided by 5? What can I multiply 5 by? What can I multiply 5 to get 0? 0. So my answer is 0 up here. Prove it. What is 0 times 5? 0. Subtract. Now am I through? Do I have any other numbers in my dividend to bring down? I do not. I'm through. I have 0, so I don't have any remainder to bring up here. And my answer is 86 per pound. Okay? All right. Arish's little trick. Did you guys remember Arish's little trick when you were solving your math test the other day, and it asked you, I think it was on your math test, it might have been a homework problem, where it asked you how many ounces in a pound? Remember? When I saw this per pound, it reminded me. You have 1 pound. LB is the abbreviation for pound. And Arish said, ooh, that looks like 16. And there are definitely 16 ounces per pound. So that's a really good trick. Arish, that's very good. I'm glad you shared that with us. Did you discover that in one of those math books that he reads, I'm sure. So he has all kinds of little tricks that he's been learning to help remember things. So, all right, that's example 2. We've got 80 cents per pound. It took us, we had to first find out how much was the total that we spent, and then we had to divide that amount to get the per pound rate. Okay, so again, it's a multiple step problem. All right, okay. Example 3, we're still on page 596. I want you to have your books open. Follow along now. Okay, so read example 3. One of the foods that Marabella feeds her pet rabbit is 2 ounces of lettuce each day. So this rabbit eats 2 ounces, OZ is the abbreviation for ounces, each day. Okay? All right, we've got that much. In how many days does her rabbit eat a pound of lettuce? Ooh, maybe Arish's little trick is going to help us on this problem. So what we don't know is how long the rabbit will take the rabbit to eat a pound of lettuce. How many pounds of lettuce does the rabbit eat in 4 months? Okay, so it's asking us a lot of questions here. All right, so let's start our working through this problem. Okay, this is the information we have. It eats 2 ounces a day. It wants to know in how many days does a rabbit eat a pound, and then how many pounds of lettuce does the rabbit eat in 4 months. All right, so the key is we start out, we know it eats 2 ounces a day. So here we go. So a pound is how many ounces? 16 ounces. Okay, so we've got 16 ounces equals 1 pound. We can start with that. And if the rabbit eats 2 ounces every day, then how many days will it take it to eat a pound? Well, we can take 16 divide it by 2. So it eats 2 every day. We want to know how long does it take to eat 16. 16 divided by 2 is 8. So it would take the rabbit 8 days to eat a pound of lettuce. Okay? So, if that's the case, now, it wants to know 4 months. And from our investigation of months, we know that every month is a different day, right? Because we start out with, if we do the knuckle method, we can start out with January is 31 days. Then in the hollow goes February, March, April, May, June, July. Okay, so how do we figure that out when it wants to know 4 months? Whenever you're doing anything mathematical, you just always take that an average month is 30 days. We always average it out to 30. We're going to get into averaging as one of our math lessons. It's one of my favorites. So, you just always take 30 days for an average month. So if we want to know 4 months, and we say the average number of days in a month is 30, what's 4 times 30? And you can use that little mental math. Just take that 0 and hang it out over here. Oh, excuse me. Allergies. Anybody else suffering from allergies? Trees. Okay. Take our 0, hang it out. What's 4 times 3? 12. Put that 0 back in there. 120. So 4 times 30 is 120 days. So if we have 120 days, and if we group those 120 days into groups of 8 days, we can find how many pounds that rabbit eats. Because we found out up here, in 8 days it eats 1 pound. So we can group these days and we can find, because you can't group your lettuce by days, so let's group our lettuce by pounds. It takes 8 days for the rabbit to eat 1 pound. So if we had 120 days, let's see what 120 divided by 8 days, 1 divided by 8, 0. 12 divided by 8, 8 will go in 1 time. 1 times 8 is 8. 12 minus 8 is 4. Bring down our 0. 40 divided by 8 is 5. 5 times 8 is 40. 40 minus 40 is 0. And there's nothing left in the dividend to bring down. So our answer is 15 days. All right? In 15 days, or sorry, not days. This is days, 120 days. It would be 15. It takes 8 days. It would eat 15 pounds of lettuce. I'm sorry, probably really confused you up there. Okay? So it would eat 15 pounds of lettuce in 4 months. Okay? And that is why a lot of times when someone is going through and showing you something on the board, you're sitting there going, right? Sometimes that's true. That's why I want you to have your book. Because if you're following along, you can be seeing in your book what it is that I'm working up here too, okay? And a lot of times that makes it easier. So I want you guys to get in the habit of using your books when I'm doing my math lessons now, okay? I never did want you to do that before because I always wanted you to be paying attention to the way, the methods, the whys. Why are you doing what you're doing? So now I want to lead you through looking at the book and following along, okay? All right. If you didn't get all of that, look at your book. Read through your book. All right? All right, let's go to example 4. Sometimes when we're doing multi-step problems, it's not always a word problem. when we have to try to find the solution to a problem. It's not always a word problem. It can be some other type of problem. And example 4 is that type of problem. It's a number line. All right? So if we have a number line, and it looks like it has, remember, we always put our numbers on the bottom. You never put your numbers on top. You always have arrows on both ends of your number line because it goes to infinity. There is no beginning, there is no end on a line. You have to show that. And then your tick marks, which are these little things here, the little ticks that shows us what place value each of these places have on the line, are always spread evenly apart. Okay? Now, I'll tell you what I don't mind if you do. If you want to use your whiteboards to do these problems with me, that's fabulous. You can do that. I just want you to have your book out too, okay? So if you want to work along with me, what I don't want you to do is spend your time messing with your whiteboard instead of paying attention to what you need to be working on, right? Because some of you like to do artwork on your whiteboard. Don't be doing that. You won't know what to do when you get to your homework, okay? All right. So it shows us, let's see, I think right here is 100, and it has a dot on the line because that shows that is a point that they want you to know, 100. And then it has a point over here. I'm gonna have to make my line bigger. And that is not labeled. And then I have a point over here, and this is 200. Okay, and this is point A. So we have 3 points on this line. Point A, point B, point C. A is worth 100, C 200, and they want to know, well, what number would B be? If A is 100 and C is 200, what would B be? Okay, so B be, what would B be? All right. If you look at your example in your book, example 4, page 597, sometimes two-step problems are not word problems. We can solve problems like this with 2 or 3 steps of arithmetic. All right. We see that the distance from point A to point C is 100. From 100 to 200, we know that's 100, okay? That's the first bit of information that we do have. The distance is divided into 4 segments. If you look right here. And guys, this was real easy to see that this was 100 to 200. You can do that in your head real easy. What if it wasn't easy? What if this was like 346 and this was 281? How do you know what that distance is? You take the higher number, in this case it's 200, and you subtract the lower number, 100. And you get what this distance is between the two. Okay? So, don't get into the habit of, oh, I see the answer. I want you to know why. Why is it 100? Because you're not always going to have problems this easy to where you can just see the answer. I want you to know how to get the number, why you're getting it that way. So if this were 346 and this were 281, you would know how to go about finding what the distance is, okay? In your math book, they give you a lot of really easy problems because they don't care that you know it's 100 right away. They want you to know how to get the answer, okay? So, and with that, I have erased our problem. So let me put that back. Okay, so we know that it's 100 between the two. Okay, we also know that B is going to be somewhere between 100 and 200. It has to be between 100 and 200 on the number line. Okay? All right. Now, the next thing we have to do is look to see how many segments is our line divided into between 100 and 200. Do not count the tick marks. Remember, never count the tick marks. Count the spaces. We have 1, 2, 3, 4. We have 4 spaces in between 100 and 200. Okay, so if you look at step 1 in example 4, 200 minus 100 equals 100. So they're showing you how you're getting that 100. Then how is that 100 divided up? The distance is divided into 4 segments. You're counting the spaces. By dividing 100 by 4, so we're going to take this number that we found, 100, and we're going to divide it up into 4 pieces. We find that each segment is 25. So every time we go this far, we've gone 25. So what is 100 plus 25? This would be 125. We go another 25, that would be 150. If we go another 25, which would be to B, 175. So we figure out that B is equal to 175. Okay? So, it says, how could we use guess and check strategy to solve this problem? Interesting. We could do that because we could say, if we didn't know, we could just say 100 to 200. We could just start out saying, oh, what if each space is worth 10? Well, this would be 110, 120, 130, 140. No, this is 200, so 10 isn't going to work. What about if we try 20? This would be 120, 140, 160, 180. No, we're trying to get to 200. See how I'm doing that? I'm just guessing and checking. What if it's 30? Well, 130, 160, 190. Ooh, that'd be 220. So I know it's going to be between 20 and 30. How about 25? Oop, I would find it. Okay, so there's a good example of a way you could use the problem-solving strategy of guess and check. Okay? All right. Let's look at our last example, the best one. Example 5. All right, we're going to do a little algebra. If y equals 2x plus 1, then what is y when x equals 3? So they told us that x equals 3. So if x equals 3, what is this going to be? All right. We're going to have to do some multi-step trying to find this out. Look at example number 5. The equation y equals 2x plus 1 shows us how to find the number that y equals when we know what the number x equals. The equation means to find y, it equals. So if you want to know the value of y, it equals what this is. And that's 2. Remember, when you have a number that snugs up right next to a letter, it means to multiply. 2 multiplied by x plus 1. If we know that, we'll know what y is. Okay? So, what the problem says is, well, what is it if we say that x is equal to 3? So let's actually rewrite our equation that way. We're going to say x is 3, so let's write it. Y equals 2 times 3, because that's what that means, 2 times x. So if x is 3, just put it in there. 2 times 3 plus 1. Now we've got to use our order of operations, which says do parentheses first. We have no parentheses. Do exponents or square roots next. We have none of those. Then you do multiplication or division. We have multiplication, so we're going to do it first. 2 times 3 is 6 plus 1. 6 plus 1 is 7. So y equals 7. So when x is 3, y is 7. All right? if you look at your problem in your book on page 597, it shows you that we have y equals 2 times 3 plus 1, and you get to 7. All right? Okay. Now, what is y when x is 5? You guys work that on your board. What is y when x is 5? You guys work that. Oops. Okay, so hopefully you got 2 times 5 is 10, plus 1, y would be 11. You see how to work that? So, those are all multi-step problems, okay? Now, anytime that we're working a math problem, you see x and y a lot. X and y are used a lot in math. And that is because when you get into algebra and math, avenues of math that are designed to trying to solve problems like this, they use x and y a lot. And actually the equation that they gave us to work on is a very famous equation in algebra. Do you remember when we did our graphing and we had a coordinate plane that looked like this, and we used the lines, and I would give you a coordinate pair, remember? And you had the mystery picture that you did. We are plotting x and y on a graph. And I know at school you might have seen walking down the hall when you went to science or library computers, the algebra students had graphs like this on the windows that they had posted. There are functions of equations that they posted on those windows. And one of those was this equation, y equals 2x plus 1. I'm not going to get into it a lot. I just want you guys to know, a lot of times you think, oh, this is easy. This is so easy. I wish we were learning something, more. Guys, what you are learning right now is so important, because you're going to be actually taking what you know now and you're going to be applying it to even larger things, okay? So, Finn's barking at the dishwasher. So, it's very important that you don't get so in a hurry that you want to learn something, fun. Oh, I already know this. Great. If you already know a lot of what we're talking about, fine. But really understand why. And because it will be very, very shortly when you get into, okay, now you're going to take this and you're just going to fly. So I'm very proud of you guys. I believe that is our math lesson. So I am going to have you guys do lesson 94, and you are going to do, did I write it down? Yes, I did. The even problems, 94 even. So get cracking, crack-a-lackin'. Somebody caught one of the problems, the math lesson, and I had 2 or 3 people. Oh, Mrs. Pullman, problem 30 said to use rectangles, and your answer key had circles. I got that wrong. You caught me. I made a mistake. You know what? It's okay. Even I make mistakes. Teachers make mistakes all the time. Any great mathematician makes mistakes. It's okay. The important part is understand what you did, okay? Now, the people who brought this to my attention explained to me why it was wrong. fabulous. Kudos to you guys, okay? It was wrong because I did not follow the directions, right? So, keep working. Keep trying. Practice makes permanent. Nobody's perfect, all right? I'm the third grade teacher and I made a mistake. It's okay. That's how you learn, okay? Not because of being careless, not because you're rushing, not because you didn't know how to do it and you just didn't want to take the time to find out. Those are unacceptable, right? But if you're trying, it's okay to make mistakes. That's how we know what we need to work on, because practice makes permanent. All right, guys. Have a good day. Love you guys.